So I'm not sure how well this is going to look up. Since we looked at the board last time, I've added a few more extra pin connectors, and I've got a power and ground hooked up here. So VCC running to pin 21, the VPP, and then the VCC pin, and then VPP, VCC, with what the schematic says here. VPP over here. VPP gets pulled up to +5, and VCC is +5 is the actual power for the part. So that's ran across, and then the grounds are going to pin 18 is grounded, and of course 12 is grounded. And I've done the same thing here. So to pin 18, to pin 12, 18, 12, 18, 12, 18, and then the same thing for the 7400 series down here. So the red and black are just what it would indicate. Black is ground, red to me is +5. That's just kind of the color code scheming I use. I'm going to use blue for the data bus. I don't have a whole lot of choice of colors here. I've got blue, yellow, and white in this pre-strip stuff, and it's easier to work with the pre-strip stuff if I can. So I'm going to go ahead and see if I can get the data bus hooked up. I've also modified the numbering over here to be data 0 to data 7. The 1 to 8 being weird there is just bothersome to me. That way it's 0 to 0 to 0. Everything's consistent across. So hopefully I can keep my head somewhat out of the way here. So data 0 on the first EEPROM. If I can get the tool loaded here, that is the shortest one, right? Data 0 is pin 9. So right here. And that goes to pin 15. That's not quite long enough. Nope, that's not going to be long enough. Actually, that's not where I meant to use this. I actually meant to be on the buffer with these shorter ones. So data 0 goes to pin 5. Hopefully it'll be long enough for this. So pin 5 on the buffer is right here. I've had a habit here of not spinning these enough and leaving a little length of wire poking up, and that goes to 49 on the edge connector, which should be that pin right there. And I need enough length here to be able to load the tool. And get up over the top of the pin. It's really difficult to do here when you can't see well. I don't know why that's being so stubborn. Oh, that did not wrap right at all. That's a horrible looking wrap. We're going to pull that off and redo it as soon as I find the correct tool here, which is of course laying around here. I've looked at it a dozen times. Oh, it's the same old story. As long as you're not using it, it's right here and obvious. Yeah, for whatever reason, that wrap walked way up the length of the pin. This is an unwrap tool. It's exactly what the name implies. It's meant for removing wire wrap connections. It of course turns in the opposite direction of the wrap and just pulls the wire wrap off like that, and and it gets thrown away. So let's change how we're going to do this. Let's start on the longer pin first. Maybe that makes more sense. So one pin up here is data 0. So let me get down over the pin. Let's see if that gets me a better looking wrap joint, and it did. That got me a completely normal looking wrap joint. And that's going to come to pin 5. Maybe, if I can get the wrap wire to load. There's a piece of insulation caught inside of there. That's really unusual. I've never seen that before. There's a little piece of blue insulation there that came out. correctly. And this comes to pin 5, which is right here. And I'm kind of pinching the wire against the PCB with my thumb to keep it from just dragging the wire until the wire is pulled taut between the two pins. So that gets me data 0 connected. Oh, come on, tool. And let's move on to data 1. Is, no, I'm off camera here, is 1 pin up on 48. Having real trouble loading the tool, and I don't know why. So that would be this pin right here. So all of the pins you see on the board here are square pins that I'm wrapping to, and there's a reason for that. Wire wrap works by the square edges of the pin cutting a little bit into the wire you're wrapping on to create a gas tight connection, and that's what keeps it from oxidizing. You can see a little bit down here on the, let me actually pull these out a bit, maybe you can see better. There's a little bit of black on the ends of these where they've been exposed to the oxygen and they've started to oxidize, which is just, you know, bad. That's because the oxygen can get to them. This was opened up. But that having the wire cut just a little tiny bit, or the sharp edge of the pin cut a little tiny bit into the wire creates, like I say, that gas tight connection. Okay, let's talk about the spaghetti here and the mess this is. So that is obviously not pretty in any sense of the word, and it's not because of the plastic spacer I've left on here. The wire doesn't drop down flush to the board. It is a rat's nest in there for the data bus. Any kind of a high-speed system, this would probably be non-functional, honestly. There'd be so much crosstalk. We're talking about a 1 megahertz Apple II computer here, and that's why I'm going to be able to get away with this. Like I say, it's not pretty. It doesn't really need to be. It just needs to work. That gets the, so that completes these 8 lines right here. That's all that does for me. And now I need to daisy chain out to all of the sockets. So it's going to be from here to this guy to here to here to here to here to here is how I'll do it. That's my shortest distance coming up this way. So a status update on the ROM board for the Apple II, and we'll do some more wire wrapping. The data bus has been wrapped, the full address bus has been wrapped. So the data bus is in blue. Yellow represents the address bus, and of course the red wires are VCC and the black wires are VSS. They've all been routed, although they're not all completely marked off here. I've actually been using the blue marker to mark things off, so let's go ahead and get the grounds marked as completed as well, though it really won't draw on tape. The grounds are all in place anyhow for everybody. So let's really now move on to this logic section. And some of these connections have already been started, but I'm going to take care of this right in here first. And I'm going to use brown, I think, wrap wire for that. I've got some brown here just to make it kind of stand out. And this we will have to be trimming and cutting ourselves. I don't have predetermined lengths of brown to use. I've kind of drawn out the chip locations because it's getting hard to read the markers. Of course, I need to find the little pair of wire cutters. I want to start out with fresh lead here. Oops. I'm just going to work my way down the list here. So B3, pin 13. B3, pin 13. to, that is actually B4. Does it say B4 here someplace? B4, yep, I'm going to write B4 in the middle of it. Well, it goes to B4 pin 13 as well, so it routes all the way across here to pin 14, which is a long run, but it is what it is. I didn't think about routing so much when I dropped the 4 TTL devices in place. It's going to route across to pin 14, which is here. And we're going to have a lead that goes from that pin 14. You know, that's the third time I have done that. Just this afternoon, the third time I have just completely said one pin number and wrapped directly onto a different one and just not even noticed. So again, we're going to take B3 pin 13. And we're going to route that to B4 pin 13. And the thing of it here is it's a 16 pin device. That's part of what threw me, is it's a larger device and I wasn't paying enough attention. So not pin 14 but pin 13, and I don't like that. It's a little bit tighter than I would have liked. It's okay. And then we go from that pin 13 to A1. So we're going to go from the A1's chip enable, which is pin 20, which is the one pin here on A1 that doesn't have any wrap wire on it. And we're going to bring that down here to pin 13. I can't see. It's going to come around to pin. How to route this? I guess it's going to go like so. No, I don't want it pulling tight. So that takes care of this one, and this one. A 4 to pin 10, and I am on pin 10. Okay, that issue's corrected. Pin 6 is an output. Open collector output. This requires this pull-up resistor here because this is an open collector device. It can't drive the output high. We mentioned that before. I am going to break at this point. My neck hurts and I'm starting to make stupid mistakes. So I will wrap this video up here. Super exciting, I know, and I'll see you in a future video.